As we go on to the last section, section 8 of chapter 2, we're going to be working with solving linear inequalities. And here is a quick review of our inequality symbols that we went over in chapter 1. Now, these are equations with an equal sign. These are inequalities with the inequality sign. Now, we solve inequalities pretty much the same way as we solve equations. There's just one major difference. And when we get to it, I'll show that to you. Now, one of the other things we're going to be doing, by the way, is what we call interval notation. This is going to be a very important way of showing answers, so we will be covering that in some detail. And we're also going to be graphing these on a number line. Okay, you can read this over. And another one is what we call set builder notation, which is what this is right here. We say that x is such that x is less than 3. That's how this is read. Now, to put this set builder notation on a graph, we used to, in high school, use this system here, where we'd make a number line. The number we're interested in is 3, and it says x is less than 3. So 3 wasn't included in the set, so we used to put a hollow. Then we'd thicken the line to the left and make an arrow, and that was the graph. Well, the way we're going to use in our college work, instead of using a hollow here, we're going to use a parenthesis that is the same meaning as the hollow. And we're then going to write it in interval notation, which is right from the graph, or this one. Where is this coming from? Well, this is coming from negative infinity out here. All of these are answers. So in interval notation, we use a parenthesis for the infinity sign. So from negative infinity up to 3. But 3 is not included because of the hollow. It's only less than 3. So we use a parenthesis. Now, if this had, and they'll be showing this here shortly, a line underneath it to indicate it's also equal to 3, this would be a solid dot, and this would change to a bracket at 3, and would then read from negative infinity up to 3, but a bracket now to indicate that 3 is part of the set. So you have to be very careful at what inequality symbol they're giving you here. Okay, and we'll be going over this as we go along. So once again, if it's greater than only, it'll be a parenthesis facing to the right. If it's less than or equal to, it's going to be a bracket facing to the left. Less than or equal to. Okay, and they're giving you some hints. Okay, so for the first one, and it's all worked out here, so let's just do it anyway. Here we have a number line, and the number we're interested in is -1. and we're interested in greater than or equal to. So we're going to make a bracket facing right, darken the line, make our arrow. So there's this graph, and that's what it means. Again, equal to means that it's included in the set. And then can you see how interval notation comes right from the graph? We're going to go -1 and then infinity. And infinity is always with a parenthesis. And let's do this one. 5 less than, so it'll be a parenthesis facing to the left. And interval notation will be -infinity up to 5. But because there's no equal sign there, it's only a parenthesis. Okay? Now, when we are solving inequalities and we're adding and subtracting something to both sides, that's exactly the same as an equation. So we've gone over that already. So let's do one here. And I'll write it out. X plus 4 is less than or equal to -6. So we're going to transpose that. That becomes a -4, so -10. And we're going to graph that, -10. And this is less than or equal to, so a bracket facing left. And then interval notation is -infinity up to -10 bracket. And that's what they have here. Now, by the way, to modify this to set builder notation, all we would have to do is put a line, put another X, and then braces. Okay? So these are the things that often go together. For this one, you're just going to transpose that. So this is going to be X. This becomes a negative. So that would be X is greater than or equal to -5. And then the graph, -5 would be a bracket. And like so. Interval notation, a bracket, -5, comma, infinity. Set builder notation. Okay, so a couple of easy things here. And again, you'd have to write this down so it becomes into your long-term memory. Remember, if this is a solution, all of the numbers less than that going to -infinity, all of these are solutions. Now, let's build this up over here. So adding and subtracting to inequalities, exactly the same as an equation. But if we had, for instance, 2 is less than 4, is that a true statement? Yes. And if we multiplied both sides by 2, we then get 4 is less than 8. Is that a true statement? Yes. Now, how about if instead of a 2, we multiplied this by a -2? This then becomes a -4, and this becomes a -8. Is that a true statement? And the answer is no, it's false. So the one thing different in solving inequalities is that when you multiply or divide by a negative, In order to keep your inequality true, you have to reverse the sign of your inequality. So now that's true. But it's only true if we reverse that, and that is a result of multiplying or dividing by a negative. Okay? And that's what they're describing down here. So I like that. They did a good job on this. Okay? And there's the summation. Now let's look at a problem here. So I'll write this one out too. We have here a negative 2x is less than or equal to a negative 4. Well, that I'm going to divide by a negative 2. In order to keep this inequality true, I have to reverse the direction of my inequality sign. So this now becomes an x, and this becomes a 2. Okay? Helpful hint. How many stars are needed to get it? Okay, and then to graph that, of course, you're interested in a 2. It's greater than or equal, so we use a bracket. And then interval notation is bracket 2 comma positive infinity. And again, you'll be working this on your practice and your quiz-mes. Now here, as long as you're dividing by a positive, you do not have to worry about changing direction. So this is x is less than negative 2. And again, because it's less than only, a parenthesis to the left, and interval notation is right there. Okay? Now, notice here we're multiplying by a positive. Does that change the direction of our inequality? And the answer is no. So it just stays the same. Over here, we are dividing by a negative. So to keep this true, we have to reverse that. And if we're multiplying by a 2, the inequality sign stays the same as long as it's positive. Here we are dividing by a negative, so the inequality sign needs to be reversed. Okay. And look at, they give us the answers right down there. Now they are repeating the steps needed to solve inequalities. All of them are the same, except if you are going to multiply or divide by a negative. In order to keep the statement true, you must reverse the sign of the inequality. Now, there is a little workaround that I'll show you right here. So negative 4x plus 7 is less than or equal to negative 9. Now notice if we transpose this negative 4x to the other side, that just becomes a positive 4x. And we transpose that, that's going to become a positive 9. and this gives us a 16. And if we now divide by 4, we get x is less than or equal to 4, which is what they have right here. Now notice, by transposing the negative 4x to the other side, we are in a sense reversing the sign, because a negative 4x is greater than, a positive 4x is going to be less than. So that's a workaround, and you don't have to worry. As long as your x is positive, you don't have to worry about reversing the sign, but in a sense, that's what we've done. So let's do this one here. Since we've been cutting short here, let's do 2x plus 7 is less than equal to x minus 11. So we'll transpose that. That'll be an x. We'll transpose that. That's going to be a negative 18. And there's our answer. In interval notation, set builder notation, it's this. Graph, negative 18, bracket, facing left. And an interval notation, negative infinity up to negative 18, bracket. Okay. Again, as I solve these, I tend to try to keep my variable positive. Doing so saves me the trouble of having to reverse the inequality sign. So here, what they're doing, and we can just follow it, get rid of the parentheses. We got this. Now, notice they're moving the 2x to this side. I would have gone this way to keep it positive, but that's okay. And you then get this. Now that you're dividing by a negative, you have to reverse. Well, here they reversed it, not there. Don't reverse it twice, just reverse it once to make it a true statement. Okay? Example 8, again, everything the same. Distribute, collect like terms. Now, if you move the negative x to this side, that would have made it a positive x. Then that would have gone to this side, but it works either way. And we'll try to keep this a little bit short here. Okay, we're going to look at now the compound inequalities. This is where you have something like x in the middle. These are compound inequalities. And how do we solve those? Well, here it's going to be a central area where x is in the middle, and here you're going to have a parenthesis facing left, and here you're going to have a parenthesis facing right. Here, because this is an inequality including an equal sign, it's going to be a bracket. Here the bracket would go there, but again it's these central areas that are shaded, and an interval notation looks like that. And now let's solve one here. So we'll write it out. Negative 1 is less than or equal to 2x minus 3 is less than 5. Now again, the technique here is to isolate the x in the middle. So I'm going to add 3, but you have to add it to all the 3 parts here. So this then becomes 2 is less than or equal to 2x is less than 8. So these cancel out. Now we're just going to divide everything by 2 to get the x by itself. And we get x is less than or equal to, oh, wait a minute, how about 1 there? Getting carried away. Was on a roll. 1 is less than or equal to x is less than 4. So to graph it, the numbers we're interested in is 1 and 4. Here this is going to be a bracket. This is going to be a parenthesis. Fill it in, and then interval notation, bracket. I don't know why I keep writing that here. A 1, comma, 4, parenthesis. And there they have it right there too. Okay, well, I think that's probably going to be it, but I don't know. Oh, one more example. Oh yes, good. Nice one with fractions. We like fractions here. Let me work this one for you too. So 3 is less than or equal to 3x over 2 plus 4 is less than or equal to 5. Good. All right, now the key here to get rid of fractions is you're going to multiply every term by your common denominator 2. So here the 2's cancel out, and we then get 6 is less than or equal to 3x plus 8 is less than or equal to 10. So all we did is get rid of that 2 by multiplying each term by 2. So now we want to isolate the x. We're going to subtract 8, subtract 8, subtract 8. We now get negative 2 is less than or equal to 3x is less than or equal to 2. And now we're going to divide everything by 3. And we get a negative 2/3 is less than or equal to x is less than or equal to 2/3. And what do you know? There you go. Okay? And you could put that in interval notation or graph it, and that will be that. Let's see if there's any more. They want us to solve an application. Okay, in solving applications, we need to be familiar with some of these words here. At least, that's going to be greater or equal. No less than, greater or equal, and these are the signs. Okay. And let's see if we can do this one here. 12 is subtracted from 3 times a number. So 3 times a number minus 12. And that is less than 21. All right, so that was not too bad. And they have that solved for us. And x is less than 11. Staying within a budget, yes. Weddings, ooh. These folks are getting married, and I see they have a female and a male. Good. But we're not saying anything else is anything. Let's move on. Our wedding reception at the gallery, reception hall, they may spend at most this for a reception. At the reception hall, charges this cleanup and $36 per person. Find the greatest number of people that they can invite and still stay within their budget. All right. This is a very typical one here. So, 2,000, and that has to be less than or equal to 2,000. They have a $100 cleanup fee, and they have a $36 per person. So there is your inequality. So as we look at it, how many people can they invite? Well, you can't invite 7/9 of a person. So it will be 52 people. So not too big a wedding, but not too bad either. And we wish them good luck. 52 people. Yep. Okay. Well, again, we spent a lot of time. We want you to be sure you're up to date on your practice quiz me mastery points. We're going to be having a test, and you've earned the right to do the test and do well on it by preparing and studying and getting mastery.